Hello, math friends. I know you have been waiting all semester for this lesson, so I will put you out of your anxious misery and get into it. This lesson is going to give you an idea of how to handle proportions and their applications, because let's face it, in the world outside of your classroom, you are not faced with many problems that look like that guy right there. You are faced with real world scenarios where setting up a proportion may come in handy. So we're going to talk about some basics. We'll review a couple of concepts from way back, and then we'll get into this word problems. Now, a long time ago in a galaxy far away, we talked about ratios, and we said that a ratio was simply a comparison of two values. Didn't matter what two values we picked. If we were comparing them, we made a ratio. So it could have been boys to girls. We could have been comparing cups of raisins to cups of peanuts and trail mix, anything. We also said that ratios could look like a fraction, or you could write it the more traditional way with a colon in the middle. We have, for the most part, chosen to look at the fraction version. And we say that two fractions, or two ratios, make a proportion. That may be a new word for you. We say they make a proportion when they are equal. So when the fractions or ratios are equal. So a quick review about how to tell whether you have a proportion or not. First thing we are going to do is multiply across our fractions. We're going to do a cross multiplying process. I know that 6 times 4 is 24. Then I'm going to multiply the opposite direction. 2 times 20 is 40. Even though my 4s, I made 2 different ways. I don't know why that happened. 24 is still not equal to 40. That equals with the line through it means not equal to, like the no parking sign. This is not equal to. Since 24 does not equal 40, 4 over 2 is not equal to 20 over 6. Great, Ms. Graham, now what? Well, that means we do not have a proportion. That's the important part. When we cross multiplied, we did not get the same product for both directions. That means we do not have a proportion. One more time, just for good measure. When I multiply this direction, 6 times 3 is 18. When I multiply this way, 9 times 2 is also 18. So here's what that tells us. I know that 18 is in fact equal to 18. What does that tell me? Well, that tells me that 6/9 is equal to 2/3. Well, what does that tell me? That tells me that we have a proportion. So the test for a proportion or not, cross multiply. If you get equal products in both directions, you have a proportion. If you get different products, remember the product is an answer to a multiplication problem, you do not have a proportion. We're going to use the same idea in solving for missing values in a proportion. I'm going to use the exact same idea with the cross multiplying. I want 10/k to be equal to 8/4, and my job as a math person is to find the one value in the entire mathematical universe that makes that true. So, just like before, I'm going to cross multiply. So I get 40. I want them to be equal. So I'm going to bring down my equal sign. And I'm going to multiply that way. K times 8 is just 8k. Now my goal is to isolate the k. Now I know a lot of you like it better when the k is on the left side of the equation. So I'm going to flip this around. So the 8k is on the left side. That makes some of you feel more comfortable, and that's okay. To undo the multiplying that is holding the 8 and the k together, we use the opposite operation or the inverse operation of multiplication. That is division. And if I do it on one side, I have to do it to the other side. (40) divided by 8 is 5. If you don't believe me, feel free to pull out Desmos and plug it in. That tells me that if k is 5, then 10/5 should be equal to 8/4. I can check it. 10 times 4 is 40. 8 times 5 is 40. Last time I checked, 40 was equal to 40. So we did it right. 5 is the only number in the whole mathematical universe that will make that proportion true. This time, the variable is in a different spot. That's okay. Don't let it trip you up. We're going to start it with the same process. So I'm going to multiply that direction. That gives me 3m. I'm going to bring down my equal sign. 10 times 10 is 100. We want to isolate that m. I'm going to make it all one color so that I can highlight the things that I change. The opposite of multiply is divide. I know that's going to make my 3's divide out. And that ends me up with 100/3 for m. And some of you are thinking, but Ms. Graham, we started out with a ratio and we wanted a proportion. How could I possibly have a fraction inside my proportion? Well, we could change our 100/3 to an approximation, a decimal approximation, we would end up with 33.3. The problem with that is if we use 33.3 and we try to multiply, when I multiply this direction, I get the 100. But when I multiply this way, I only get 99.9, and that does not create a proportion. We need exactly 100 on both sides. So here's what happens when I want to use an exact value. To check it, I am going to put 100 over 3, that's a 3, over 10. I'm putting it in that spot right there. And I want to know if that will be equal to 10 over 3. Now you guys have access to Desmos Scientific, so I'm going to pull that up over here on the right side of my screen. I'm going to cross multiply. So I'm going to do 3 times 100 over 3. Now, if multiplying fractions by hand makes you a little twitchy, that's okay. Come over here to Desmos, and we'll do 3 times. I'm going to hit my fraction button. I'm going to put 100 in the numerator and 3 in the denominator. I get a 100. Miss Graham, is that a coincidence? Like, is that always going to happen? Well, here's what's really going on. If I want to multiply fractions, I'm going to put that first 3 over 1 so that we have 2 fractions to multiply. And I'm going to multiply straight across. That gives me 300 divided by 3. And even without a calculator, I know that's going to be 100. That's why Desmos gives you a 100 when you plug that in. So I am going to erase that little field trip. So we now know that 3 times 100 over 3 is just 100. When I multiply this direction, I get 100. And 100 is indeed equal to 100. So we have a proportion where our final answer, the one number in the whole universe that makes that proportion true, is 100 over 3, and that is an exact value. It is not an approximation. I'm going to move these up. Three is a little bit different. Most of these get made with a purpose, and I had a purpose when I put this one in here. The other two, we had a 1 in front of the variable, so that made the multiplying really, really simple. This time, though, we're going to up the ante a little bit, and I put a coefficient in front of that n. I gave it a coefficient. That's a fancy way to say the number in front. I made it an 8 instead of a 1. Same process. Multiply this direction. When you multiply a coefficient and a variable, so the 8n, by a 3, what you're really doing is 3 times 8 and putting the n on the back. So that becomes 24n. Then I'm going to multiply the other way, and I get a 64. Again, we want to use an opposite operation. to isolate the n, 24 times n is what we've got. So to undo multiply, we divide. My 24s will divide out. And then I'm going to come over here to Desmos. And I am going to ask it to please simplify 64 over 24 for me. So I get 8 over 3. I'm going to go check it just in case. So I have an 8, and then I'm going to plug in what I think my answer is. So 8 times n over 8. And I want to know if that is equal to 8 over 3. Same idea as the last one. I am going to cross multiply that direction. So I have 8 times 8 over 3 times 3. On the right side, 8 times 8 is 64. Well, I'm going to work on the left side a little bit. I'm going to put this over 1, and I'm going to put this over 1. You are welcome to do it by hand. You are welcome to go put it in Desmos. For those of you who are my calculator people, this is what it would look like plugged in. I would put, actually, if you're going to do it in the calculator, you don't need the ones. 8 times 8 over 3 times 3. So I get 64. For my people who like to do things by hand, this is the same as, I could do 8 times 8 is 64 times 3 and then divide by 3. Or I can work smarter instead of harder. I know because this is all multiplication, I have a 3 in the numerator and a 3 in the denominator. Those are going to divide out. 3 over 3 is a 1. So we really have a 1 in disguise. What I have left is 8 times 8. Well, I know 8 times 8 is 64. And 64 is still 64. This works. So we have a proportion where our missing variable has an exact value of 8 over 3. 4 is very similar. I am not going to beat a dead horse. Let's move on to look at some word problems. Number 1, since we have a ratio of boys to girls in an elementary school, is 3 to 2. If there are 126 boys in the school, how many girls are there? These can be a little intimidating because it sounds like there's a whole lot of information in there. So what I'm going to do is try to simplify that a little bit. What we have is boys to girls. So I am going to set up a ratio that compares, where'd my line go? Okay. Boys to girls. Well, when you are given a ratio, the ratio of boys to girls is 3 to 2. These numbers in the ratio go in the same order as the initial ratio. So that means 3 boys for every 2 girls. But I was also given some more information. If There are 126 boys. Okay, well, I'm going to put that on top with the boys. How many girls are there? So when I set it up like that, where all of the blue pieces are on the top, all of the pink ones are on the bottom, I can pull out just that piece to solve. So I'm going to cross multiply. I know that G times 3 is 3G. I know that 2 times 126 is 252. I'm still dealing with multiplication, so I want to divide in order to isolate the G. If I want to do 252 divided by 3, I get 84. So what does that mean in terms of our problem situation? That means that if we have 126 boys with a ratio of 3 boys for every 2 girls, we have 84 girls in the school. So let's look at a different one. You decide to celebrate graduation with a crawfish boil for you and your friends. 55 pounds of crawfish usually feeds 9 people. How many pounds will you need to feed 40 people? I don't even think I know 40 people, but that's okay. I'm going to set this up the same way I did the other ones. We have 2 quantities. We have crawfish and people. So I'm going to put crawfish across the top and people across the bottom. 55 pounds of crawfish. So 55 pounds usually feeds 9 people. I already decided that my people were going to be in the denominator. So my 9 people go in the denominator. How many pounds will you need to feed 40 people? Well, 40 is people, so it goes in the denominator. And the question was, how many pounds of crawfish? So we need X pounds of crawfish. Just like before, we're going to cross multiply. So I end up with 9X equals 55 times 40. I want to divide by 9 so I can isolate that X. This is 244. 0.4 repeating pounds of crawfish. Now, if you try to go buy crawfish, and I don't know if you've done this before or not, but usually you buy them by the big giant bag, or sometimes you can find places that'll sell you half a bag. Either way, If you go to try to buy 0.4 repeating pounds of crawfish, you are going to get laughed away from the crawfish. So, in order to have enough, we really need to order 245 pounds of crawfish. So for our problem situation, we need 245 pounds. I think you might be able to find them in 25-pound bags. Sometimes they're 50-pound bags. Either way, that's a lot of crawfish. Okay, so James works odd jobs after school to make some extra money. He was paid $160 for 20 hours of work. If he is paid at the same rate, how much will he be paid for 37 hours of work? So here we go. I'm going to set up my ratios. I may not need all three of those, so I'm going to hold off. Yeah, I'm going to use all three. So we've got money and hours. So I'm going to put money on top, hours in the denominator. This guy gets $160. That's money, so it's going to go on the top. For 20 hours of work. So I'm going to put that in the denominator. I'm so excited, I can barely say the word. With the rest of the hours. How much will he be paid? So they're asking me how much money he's going to get. That tells me I need an X with the dollars for 37 hours of work. So I need to put 37 in the denominator with the rest of the hours. Cross multiply like we've been doing. I'm going to get 160 times 37. I want to isolate the X, same story as before. The inverse operation for multiplying is dividing. My 20s will divide out. And I need to divide 5,920, not 10, 20, by 20. That is 296. But we are in a real world situation. We need to make sure that we put the appropriate units on our answer. So, for 37 hours, he is paid $296. Last one. At a certain temperature, it takes 50 minutes per pound to smoke a brisket. At the same temperature, how long would you expect to smoke a 16-pound brisket? This problem is very similar to something you would use to figure out how long to cook a turkey at Thanksgiving. If you think that might be something that's in your future one day, this is perfect for that. We have two quantities. This time we have time and we have pounds. I'm going to set it up all the way across. I should have been consistent, so I'm going to fix my notation colors before I get a strongly worded email. There we go. How long would you expect to smoke a 16-pound brisket? So we're looking for time. I'm going to use a T this time. We have a 16-pound brisket. Initially, we were told 50 minutes. Per pound. Well, that's sneaky right there, because what you are not told, it's sort of implied that we're only looking at 1 pound. That's a tiny little brisket. Do those even exist? Okay. So we've got 50 minutes for 1 pound. We want to know how many minutes for 16 pounds. So we cross multiply. 50, not 51, 50 times 16 is 800. Now, I don't know if you are really good at converting minutes to hours. I don't have a good feel for how long 800 minutes really is. So I am going to convert that to hours and minutes to see what I'm really looking at here. So I am going to use an idea called dimensional analysis from probably your science classes. This is not something you have to be able to do. This is so we have a better idea of what 800 minutes looks like. I know that there is 1 hour full of 60 minutes. But I need my units to cancel out, so I'm going to put 60 minutes in the denominator, and I know that's equal to 1 hour. What that does is it helps me not have to remember when I'm supposed to multiply and when I'm supposed to divide. If I line up my minutes so that they will cancel out, I don't have to worry about it. So I'm going to do 800 divided by 60. Of course, it's going to be a repeating decimal. Why wouldn't it be a repeating decimal? So this is 13 1/3 hours. A third of an hour is 20 minutes. So 800 minutes is approximately 13 hours and 20 minutes.